People commonly believe that escape is always a matter of technology, that if something appears impossible today, it is merely because the correct engine has not been built yet, the correct material has not yet been discovered, the correct theory has not yet been written. This belief is so deeply embedded in modern thinking that it rarely feels like a belief at all. It feels like a law of reality, a quiet assumption that progress eventually solves everything. When faced with black holes, this assumption does not disappear, it simply changes costume. We are told that black holes are extreme but not absolute, that their dangers are staggering but not final, that somewhere in some distant future, a civilization sufficiently advanced could approach one, study it, perhaps even enter it, and maybe under the right conditions, leave again, not easily, not safely, but in principle. The phrase "in principle" does enormous psychological work. It creates the illusion of openness. It implies that physical law is flexible if intelligence becomes clever enough. It implies that impossibility is just a placeholder for ignorance. This belief feels rational. It feels scientific. It feels aligned with centuries of human progress, where boundaries once thought unbreakable were eventually crossed. We once believed heavier than air, flight was impossible. We once believed the speed of sound was an ultimate barrier. We once believed that the atom was indivisible. Each time history appears to teach the same lesson: never say never. And so when people hear the statement that escaping a black hole is impossible, they instinctively translate it into softer language. Impossible with current physics. Impossible with current understanding. Impossible for us, but maybe not for something smarter. The word impossible is quietly downgraded to difficult. This downgrade feels reasonable. It is also wrong. The discomfort begins when one notices that black holes are not obstacles in the usual sense. They are not walls. They are not traps made of matter. They are not violent storms that might calm down. A black hole is not a thing in space. It is a structure of space itself. That distinction is subtle, but it is fatal to the belief in escape. Because every historical example of overcoming an impossibility shared a hidden feature. The impossibility existed inside the laws of physics. Flying was impossible until we learned how to manipulate aerodynamic forces. Breaking the sound barrier was impossible until we learned how pressure waves behave. Splitting the atom was impossible until we learned how nuclear forces work. In each case, physics allowed the outcome all along. Human beings simply did not yet know how. Black holes are different. Their defining feature is not an engineering challenge. Their defining feature is that they emerge directly from the deepest structure of space-time itself. They are not violations of physics, they are perfect expressions of it. This alone should provoke unease. If black holes exist because the equations of reality demand their existence, then any claim about escaping one must be measured not against engineering potential, but against whether reality permits such a state at all. Not whether humans can build something, not whether intelligence can become advanced, but whether the universe contains any allowable pathway in which escape occurs. This is a much colder question because physics does not negotiate, physics does not care about survival, physics does not adjust itself in response to intelligence. It simply enforces relationships between energy and curvature, between mass and geometry, between time and causality. Black holes arise when those relationships reach a specific threshold. Once that threshold is crossed, the structure of reality reorganizes, not metaphorically, literally. Space tilts inward, time tilts inward, all possible futures tilt inward. This is not poetic language. It is geometric description. Inside a black hole, inward is not a direction, inward is time, and time does not allow reverse travel. At this point, the belief in future escape technologies begins to look less like optimism and more like denial. Because what would an escape require? It would require a way to move into the future while simultaneously moving against the flow of all possible futures. It would require a trajectory that does not exist, not one that is hard to follow, not one that requires enormous energy, but one that is absent from the map of reality. People often imagine black holes as cosmic whirlpools. If you could just apply enough thrust, perhaps you could swim outward. This image is comforting. It is also completely false. A whirlpool exists inside space. A black hole is a deformation of space. In a whirlpool, the water flows inward, but the surrounding space remains normal. In a black hole, space itself flows inward. Trying to escape is not like swimming against a current. It is like attempting to walk north from a point where all directions are south. Language begins to fail here, but the failure itself is instructive. Our brains evolved to navigate environments where space and time behave gently. We intuitively treat time as a background river and space as a stable stage. Black holes expose that these intuitions are approximations, not truths. In everyday life, the future always lies ahead. Inside a black hole, the singularity lies ahead, not spatially ahead, temporally ahead. Every moment that passes carries an object closer to the center in the same way that every moment carries you closer to tomorrow. You do not fall toward the singularity, you age toward it. This single fact quietly destroys the concept of escape, because escape would require traveling backward in time, not symbolically, not figuratively, but causally. And causality is not a local engineering problem. It is the backbone of the universe. Even the most speculative theories in physics, the ones that imagine wormholes or exotic geometries, preserve causality at a fundamental level. They twist it, they stretch it, they never permit its casual violation. The reason is simple. Without causality, no physical law can exist, no prediction holds, no equation means anything. A universe that allows unrestricted backward causation is not a universe that supports structure, stars, chemistry, or observers. It collapses into noise. The same mathematics that predicts black holes also predicts this, which leads to a deeply unsettling realization. Black holes are not prisons built by nature. They are boundaries written into reality. They mark a region where the concept of later points inward, not outward, not sideways, inward, the popular belief that sufficiently advanced beings might someday escape a black hole depends on an assumption that physics contains hidden loopholes, that the universe secretly allows contradictions if intelligence becomes clever enough. No serious physical theory has ever suggested this. Every successful theory has done the opposite. It has removed loopholes, it has tightened constraints, it has revealed that reality is less permissive than intuition suggests. The more deeply we understand the universe, the fewer degrees of freedom we discover, not more. This historical trend matters. It means that betting on future physics to restore escape is not consistent with the trajectory of scientific discovery. It is the opposite. Discovery tends to replace soft impossibilities with hard ones. Black holes appear to be one of those hard boundaries. They are not regions where physics breaks. They are regions where physics finishes making compromises. They represent the point at which the geometry of space-time becomes so extreme that certain concepts simply stop existing, not hidden, not inaccessible, non-existent. One of those concepts is away. There is no away from the interior of a black hole. There is only later, and later always points inward. This is not a failure of imagination. It is a feature of reality. The paradox is now fully exposed. Human intuition insists that escape must always be possible in principle. Black holes exist precisely because some futures do not exist. These two ideas cannot both be true. One of them must be surrendered, and it will not be the black hole. Escaping a black hole is not a technological problem. It is not a theoretical gap. It is not a question awaiting cleverness. It is a category error about what kinds of futures the universe allows. Escaping a black hole is impossible because the universe does not contain a version of time in which escape occurs. To understand why no future technology can alter this conclusion, one must first remove a deeply ingrained misconception. The misconception is that physical laws are negotiable. They are often described as if they were policies, provisional rules waiting to be amended by better understanding. This framing is psychologically comforting, but it is structurally wrong. Physical laws are not prescriptions, they are descriptions. They do not tell reality how to behave, they record how reality behaves. When Newton described gravity, he did not create gravitational attraction. When Einstein described space-time curvature, he did not introduce curvature into the universe. He uncovered patterns that were already there. This distinction matters because it determines what improvement in knowledge can accomplish. Improved knowledge reveals what is true. It does not create new kinds of truth. If the structure of space-time inside a black hole forbids outward directed, future paths, no amount of cleverness can introduce them. Knowledge can map the cage. It cannot dissolve it. General relativity predicts black holes with unnerving precision, not as exotic possibilities, not as speculative anomalies, as inevitable consequences of mass, energy, and geometry interacting exactly as observed. The equations allow no exceptions. If enough mass is compressed into a small enough volume, space-time curvature increases. If curvature increases past a critical threshold, an event horizon forms. If an event horizon forms, all future directed paths inside that horizon terminate at the singularity. This is not philosophical, it is mathematical. The equations do not say that escape is very difficult. They do not say escape requires infinite energy. They do not say escape is improbable. They say there are no future directed trajectories that lead outward, none, zero. This is an ontological statement about the structure of the solution. It describes what kinds of histories can exist. Once inside the horizon, every possible future world line points inward. World line is a technical term. It means the path an object takes through space-time, not through space alone, through space and time together. In ordinary life, you imagine your world line as a mostly vertical line through time, drifting slightly through space as you move. Inside a black hole, all world lines tilt toward the singularity, not because of force, not because of acceleration, but because geometry itself has rotated. This rotation is not visual, it is causal. The future is no longer forward, the future is downward, toward the center. This is why no engine helps. Engines produce acceleration. Acceleration changes velocity. Velocity determines how your world line tilts relative to space. But inside the horizon, tilting your world line relative to space does nothing. The direction that needs to be altered is the direction of time. No physical process alters the arrow of time, not locally, not globally, not theoretically. Time's arrow emerges from the same statistical and thermodynamic foundations that allow stars to shine and atoms to exist. Reversing it is not analogous to reversing a motor. It is analogous to reversing entropy itself, which means erasing the statistical tendency of matter to explore larger numbers of microscopic configurations. This is not something that can be engineered. It is not something that can be powered. It is not something that can be hacked. It is the underlying bookkeeping rule of the universe. Every proposal for escaping a black hole eventually smuggles in a violation of this rule. Sometimes the violation is hidden inside speculative space-time geometries. Sometimes it appears in the form of negative energy. Sometimes it appears as hypothetical exotic matter. But in every case, the proposal relies on allowing physical conditions that, if they existed, would destabilize the universe everywhere, not just inside black holes. This is another uncomfortable fact. Physics does not allow special exceptions in isolated locations. If a law can be violated somewhere, it can be violated anywhere, which means that any mechanism powerful enough to permit escape from a black hole would also permit causality violations throughout the cosmos. You would not merely gain escape, you would destroy the logical consistency of reality. This is why serious physicists treat black hole horizons as absolute boundaries. not out of dogma, out of structural necessity. The universe only works at all because certain things never happen. Objects do not spontaneously unburn. Effects do not precede causes. Entropy does not globally decrease. Information does not propagate backward. In time, black holes exist at the intersection of these constraints. They are not cosmic monsters. They are the purest expressions of order. Order in the sense of strict rule following. The event horizon is not a wall, it is a causal partition. On one side, events can influence the outside universe. On the other side, they cannot, not because something blocks the signal, but because there exists no path through space-time that carries that signal outward. This distinction eliminates another comforting fantasy. The fantasy that escape might be possible but simply undetectable. That perhaps something leaves but we cannot see it. Physics does not care what we can see. It cares what can exist. If no outward directed world lines exist, then no outward directed histories exist, which means no escape histories exist. Not hidden, not subtle, not undiscovered, non-existent. It is tempting to imagine that quantum mechanics might provide a loophole. Quantum theory often feels like a realm where anything might happen. Particles tunnel through barriers. States exist in superposition. Uncertainty appears fundamental. This emotional impression has misled many people. Quantum mechanics does not abolish structure. It refines it. Quantum behavior obeys equations that are at least as strict as classical ones, often stricter. When quantum field theory is applied to curved spacetime, as in black holes, it does not resurrect escape paths. It reinforces the horizon. Quantum effects near the horizon produce radiation, Hawking radiation. This fact is frequently misunderstood. Hawking radiation does not come from inside the black hole. It arises from quantum flu, situations just outside the horizon. No information-bearing signal travels from the interior to produce it. The black hole loses mass. It shrinks, but nothing that has crossed the horizon ever returns. Evaporation does not reverse infall. It merely reduces the size of the region from which escape is impossible. Anything already inside remains inside until the singularity is reached. Even if the black hole eventually evaporates completely, the internal histories do not suddenly reconnect to the outside. They end. This is another deeply counterintuitive point. We instinctively treat disappearance as a kind of release. But evaporation is not a door opening. It is a door vanishing. If you are sealed inside a collapsing building and the building slowly erodes from the outside, your interior does not magically gain a corridor to the street. Your interior simply ceases to be part of the world. This sounds philosophical. It is not. It is a statement about space-time topology. Once regions become causally disconnected, later changes to surrounding geometry do not retroactively reconnect past separations. Time does not heal causal wounds. It deepens them. Every year that passes after an event horizon forms pushes interior histories further into isolation, not spatial isolation, temporal isolation. The belief that black holes might someday be escaped relies on an intuition formed in small, gentle environments, an intuition that treats space as a container and time as a passive background. Black holes reveal that both are dynamic. They bend, they twist, they acquire directions. Inside a black hole, the universe has already decided what happens next, not probabilistically, not approximately, exactly. The singularity is not a place you might avoid. It is a moment you will reach. Every internal clock counts down toward it in the same way every external clock counts toward tomorrow. No future civilization alters the structure of causality. No intelligence rewrites the geometry of time. No technology invents new classes of possible histories. Progress does not expand what is logically allowed. It only explores what was always allowed. Black holes sit at the edge of that allowance. They are the point at which possibility runs out, not gradually, not ambiguously, completely. The uncomfortable implication is now unavoidable. If you cross an event horizon, you do not become trapped in a difficult situation. You cease to inhabit a universe in which escape exists as a concept. Your future is not constrained. Your future is defined, and definition is stronger than constraint. Very well. Human language was not designed to describe finality. It evolved to describe environments where reversal is usually possible. Spilled water can be wiped up. A broken tool can be repaired, a lost path can be retraced. Even death in everyday psychology is often treated as a special case rather than the rule. This cognitive background quietly shapes how people think about black holes. They imagine an extreme version of danger. They imagine the worst possible trap. But they still imagine a trap. A trap implies an outside. A trap implies an interior and an exterior connected by a boundary that could, under extraordinary circumstances, be crossed. Black holes are not traps. They are topological terminations. Not merely restrain motion. They eliminate categories of motion. This distinction becomes clearer when one considers what movement actually means. Movement is not something that happens purely in space. It is something that happens in space-time. When you walk across a room, you are not only changing your spatial position, you are also advancing through time. Every action you take is a combination of spatial displacement and temporal progression. Physics encodes this as a four-dimensional trajectory. Inside a black hole, spatial freedom still appears to exist in local terms. You can move your arms, you can rotate, you can fire rockets. Nothing feels immediately different at the horizon. This fact is often cited as evidence that the horizon is not special. This conclusion is mistaken. The horizon is not special in terms of local sensation. It is special in terms of global structure. The difference between these two is the difference between standing on a calm ocean surface and standing above a tectonic fault. Nothing in your immediate sensations reveals the fault, yet the future of the ground beneath you is already determined. Local physics does not encode global destiny. Global geometry does. The horizon marks the point at which the global geometry changes irreversibly. Outside the horizon, space-time admits world lines that point outward. Inside, it does not. The interior is not a region of strong gravity in the everyday sense. Gravity as a force largely disappears in general relativity. What remains is geometry. Objects move along geodesics, the straightest possible paths through curved space-time. Inside a black hole, all geodesics point toward the singularity. Not because they are pulled, but because there exists no other straight direction. This is equivalent to standing on the surface of a sphere and walking straight. You eventually return to your starting point, not because you chose to, but because straight lines on that surface close. Inside a black hole, straight lines close on the singularity. This geometric inevitability explains why stronger engines never help. An engine changes how you move relative to your local frame. It does not alter the geometry of space-time itself. You cannot thrust your way into a different topology. People sometimes imagine that with enough energy, space-time could be reshaped. This idea confuses scale with category. Energy curves space-time. Yes, but the amount of energy required to significantly alter black hole geometry is comparable to the energy that created the black hole in the first place. To flatten the interior geometry, you would need to remove the mass energy causing the curvature, which means removing the black hole, not escaping it. This is like proposing to escape a burning building by eliminating the building from existence. If you succeed, the building never existed. Your escape becomes meaningless. More importantly, removing the black hole from inside is impossible for the same causal reason escape is impossible. Any attempt to alter the mass energy distribution would require sending influence outward, but outward directions do not exist. Causality flows inward only. This is a self-sealing structure. The more carefully one examines it, the more complete the closure becomes. Another deeply embedded intuition must now be company. Fronted, the intuition that information can always, in principle, be preserved. In everyday experience, destruction feels reversible. Burned books could be rewritten, shattered hard drives could be reconstructed if we knew enough about their microscopic state. This intuition underlies the belief that nothing is ever truly lost. Black holes challenge this intuition at its foundation. When something crosses the horizon, it does not merely become hidden, it becomes causally disconnected. The outside universe does not lack access to the information. It lacks a future in which access occurs. This distinction matters. Hidden implies recoverable. Disconnected implies non-existent from the perspective of the outside. Modern physics has wrestled with this problem for decades. The so-called information paradox arose precisely because physicists were reluctant to accept this implication. They searched for subtle channels by which information might leak out, not because evidence demanded it, but because intuition resisted finality. The resolution that has gradually emerged is not that escape occurs. It is that information is preserved in correlations at the horizon, not in the sense of objects returning, but in the sense that the universe maintains internal consistency. Nothing ever climbs back out. The horizon does not function as a door. It functions as a boundary condition. Once crossed, the object becomes part of the interior solution of space-time. Interior solutions do not connect to exterior ones in future time. This idea is difficult because it forces a redefinition of existence. Existence is not simply being somewhere. Existence is participation in a shared causal network. If no future event outside the black hole can ever be influenced by an interior event, then interior events do not exist relative to the outside universe, not metaphorically, physically. They have no causal representation. This is not annihilation. It is not transformation. It is causal extinction. From the outside, nothing inside ever happens. From the inside, the outside rapidly ceases to have meaning. Both descriptions are correct within their own causal domains. This duality is not a contradiction. It is a consequence of space-time partitioning. The belief in eventual escape usually rests on a final fallback, that perhaps some deeper theory beyond general relativity will soften these conclusions. This belief misunderstands the relationship between old and new theories. New theories do not abolish the successful predictions of old ones. They contain them as limiting cases. Quantum mechanics did not prove Newton wrong in the domain where Newton works. Relativity did not abolish classical mechanics at everyday speeds. They refined and extended. Any future theory of quantum gravity must reproduce general relativity wherever general relativity has been experimentally confirmed. Black hole horizons fall squarely in that category. Their existence is not a speculative prediction. It is supported by multiple independent lines of observation, stellar orbits around galactic centers, gravitational wave signatures from mergers, accretion disk behavior, event horizon scale imaging. Any deeper theory must therefore include horizons, not erase them. It may describe them in richer language. It may encode their microstates. It may explain their entropy. It will not turn them into permeable membranes that allow outward causal flow, because doing so would contradict the very experiments the theory must match. Thus, the hope that future physics will save us is not grounded in how physics progresses. It is grounded in emotional discomfort with limits. Black holes represent a limit that does not negotiate, not because nature is cruel, not because reality is hostile, but because consistency requires boundaries. A universe without hard boundaries is a universe without stable structure. Every system depends on certain transitions never occurring. Black holes are one such transition point. They mark where future directed connection ends, not symbolically, not practically, fundamentally. You are not trapped inside a black hole in the way a prisoner is trapped inside a cell. A prisoner exists in a world where release remains a possible future. Inside a black hole, release is not a possible future. There is no waiting, There is no rescue. There is no improbable miracle. There is only progression toward a defined terminus. The singularity is not merely a place of destruction. It is the end of the concept of later. When later ends, possibility ends with it. The mind instinctively resists accepting that any physical process can possess true finality. This resistance is not philosophical. It is biological. Human cognition evolved in an environment where permanence rarely existed. Storms passed, wounds healed, predators moved on. Even death, while irreversible for the individual, did not feel like a universal rule. Life continued, patterns repeated. This evolutionary background, D, quietly trains the brain to treat extreme claims with suspicion. Nothing can ever escape sounds like an exaggeration, a rhetorical flourish, a temporary limit waiting to be broken. Black holes expose the flaw in this instinct. They do not represent an extreme version of ordinary danger. They represent a different category of structure altogether. To see this clearly, one must examine the difference between force and geometry. In everyday thinking, gravity feels like a pull, a downward force, something that can be resisted by pushing upward. This intuition is a residue of Newtonian physics. In Einstein's description, gravity is not a force, it is curvature. Mass and energy tell space-time how to bend. Space-time tells objects how to move. Objects do not fall because they are pulled. They fall because they are following the straightest possible path through curved geometry. This reinterpretation is not philosophical. It produces precise numerical predictions that match observation. Inside a black hole, the curvature becomes extreme. So extreme that the distinction between space and time partially collapses. Outside the horizon, you can choose to move in space or remain still. You cannot choose to stop moving through time. Inside the horizon, you cannot choose to stop moving toward the singularity. This is not poetic. It is literal. The singularity occupies the role that future normally occupies. Trying to avoid it is like trying to avoid tomorrow. No engine allows you to remain at 3 p.m. forever. No rocket allows you to turn around and move toward yesterday. The analogy is exact. The singularity is not a place you approach. It is a moment. To you approach. This reclassification destroys a large class of imagined escape mechanisms. Any mechanism involving thrust assumes that the problem is spatial. It assumes there exists an outward direction that simply requires enough energy. But the problem is temporal. The outward direction is pastward. And physics does not permit macroscopic systems to move into their own past. Even theoretical constructs like closed time-like curves, which appear in certain exotic solutions, are heavily constrained and likely unphysical in real universes. More importantly, even if such curves existed somewhere, they do not appear inside realistic black hole interiors in ways that allow outward escape. The geometry is not permissive, it is convergent. Everything converges. Another layer of misunderstanding comes from visual metaphors. Popular illustrations show black holes as funnels or pits. These images are pedagogical shortcuts. They embed a dangerous assumption that space curves into an external dimension, as if the universe were a rubber sheet sagging into a higher dimensional void. In reality, space-time curvature does not require an embedding space. There is no downward direction into which space sinks. Curvature is intrinsic. It is encoded entirely within the relationships between distances and times inside the manifold. This matters because the funnel image invites the idea that one could climb back up. But there is no up. There is only geometry that dictates how intervals relate. Inside a black hole, those relations admit only inward-pointing futures. This is not a region of extreme gravitational strength. It is a region of extreme causal orientation. The difference is subtle. Strength implies magnitude. Orientation implies direction. You can overpower strength. You cannot overpower orientation. Consider an analogy. Imagine living in a universe where time only flows north. No matter how fast you run east or west, you are still carried north by time. You can zigzag, you can sprint, you can crawl, but every second that passes moves you north. Escaping a black hole would require inventing a way to move south in time, not slow down, not pause, move backward. All physical processes we know generate entropy. Entropy increase defines time's arrow. Reversing it locally would require assembling an astronomically precise arrangement of microscopic states. Doing so globally and sustainably is beyond absurd. It contradicts statistical mechanics itself. Statistical mechanics is not an approximate rule. It is the mathematical expression of counting. It states that systems overwhelmingly evolve toward configurations that can be realized in many microscopic ways. There are vastly more disordered states than ordered ones. This is not philosophy. It is combinatorics. Black hole interiors represent the maximal express ion of this tendency. Matter becomes compressed. Degrees of freedom become inaccessible. Entropy skyrockets. The idea that an object could locally reverse this process while embedded inside a geometry that itself points toward increasing entropy is not merely unsupported, it is mathematically incoherent. Sometimes people propose that an advanced civilization could surround a black hole and manipulate it externally, extract mass, control spin, control charge, perhaps engineer conditions that open the horizon. These proposals confuse boundary manipulation with interior liberation. You can change properties of a black hole from outside. You cannot alter the causal past of the interior. Once the horizon has formed and something has crossed it, no future manipulation outside affects the interior history in a way that allows escape. Causality does not run backward. You can starve a black hole. You can make it evaporate. You cannot retroactively create outward world lines that never existed. This asymmetry is central. Human planning often assumes that future actions can repair past mistakes. This assumption holds in many everyday contexts. It fails completely in relativistic spacetime. Relativity reveals that certain past events permanently reshape the space of future possibilities. Crossing an event horizon is one of those events. It is a one-way transition in the most literal sense, not a one-way door, a one-way existence class. After crossing, you no longer belong to the class of objects whose future includes the external universe. You belong to a different class entirely. This classification is not negotiable. It is not subject to reinterpreter. Shion. It is not softened by optimism. It is encoded in the metric. In this sense, black holes are not prisons. Prisons imply captivity. Captivity implies the captive remains part of the same social and legal framework as the outside world. Black holes represent exile from the causal order that defines outside at all. Exile is still too gentle a word, because exile implies survival elsewhere. Inside a black hole, elsewhere disappears. There is only later and later terminates. Another intuition must now be dismantled. The intuition that the singularity itself is the real danger, that if one could somehow avoid being crushed, perhaps by some unknown physical effect, escape might become possible. This shifts attention away from the horizon where the real finality occurs. The singularity is not the reason escape is impossible. The horizon is, the singularity is simply the end point of the interior's time. Even if quantum gravity were to smooth out the singularity, even if the infinite curvature were replaced with some finite but extreme structure, the causal orientation would remain, the future would still point inward, the inability to escape would remain. This is a crucial point. Escaping a black hole does not fail because objects are destroyed. It fails because the concept of outward future ceases to exist. Destruction is secondary. People fixate on spaghettification, on crushing gravity, on high-energy environments. These are distractions. They are consequences, not causes. Even a perfectly gentle black hole, even one with tidal forces so weak that you could cross the horizon without noticing, still forbids escape because the prohibition is geometric, not mechanical. The more one strips away sensational imagery, the starker the reality becomes. There is nothing dramatic about the impossibility, no explosion, no final scream, just a quiet absence of paths, no doors, no corridors, no routes, only one direction left, the direction called future, and inside a black hole, future has only one destination. A common psychological refuge when confronted with absolute limits is scale. If something is impossible for individuals, perhaps it becomes possible for civilizations. If impossible for civilizations, perhaps for post-civilizational intelligences. If impossible for intelligences, perhaps for entities that no longer resemble matter at all. This scaling upward feels reasonable. History appears to support it. Small groups achieve little, large groups reshape continents, primitive societies build huts, advanced societies build particle accelerators. The pattern seems consistent. Bigger scale equals access to deeper power. Black holes quietly invalidate this pattern. They are not challenges of insufficient power. They are boundaries of permitted structure. No increase in scale alters permitted structure. A civilization the size of a galaxy still operates inside space-time. A mind spread across stars still inhabits causality. A post-biological intelligence still exists within time. Black holes are limits imposed on all entities that exist, not just biological ones, not just material ones. Existence itself, as defined by participation in space-time, inherits these limits. This is why proposals involving becoming energy or becoming information do not help. Energy follows G. Odessics, information propagates along causal curves. Both obey the same geometry. Nothing that exists can step outside the geometry that defines existence. Even hypothetical exotic entities, if they interact with the universe at all, must obey causal structure. Otherwise, they would have no observable meaning. Something that does not participate in causal structure cannot be said to exist in any physically coherent sense. It produces no effects. It leaves no traces. It cannot be detected. Calling such a thing an escapee is meaningless. Escape implies departure from one causal region into another. If causal structure does not allow such a departure, the word escape loses definition. This is an important conceptual collapse. People often imagine impossibility as a barrier, but in black holes, impossibility is closer to erasure. The set of futures in which escape occurs is empty, not extremely small, not astronomically unlikely, empty. This distinction cannot be overstated. Probability applies to outcomes that exist within a sample space. There is no sample space containing escape trajectories, which means escape has no probability, not low, zero. This alone should end the discussion. Yet the mind resists. So another refuge is sought. Perhaps black holes connect to other universes. Perhaps they are gateways. Perhaps falling in somewhere allows emergence elsewhere. This idea appears frequently in speculative fiction and occasionally in speculative physics. It arises from mathematical extensions of solutions, not from evidence. Even if such connections existed, they would not constitute escape. They would constitute termination in this universe. Say, from the perspective of the original exterior, nothing returns, nothing communicates, nothing influences. The object is gone. Whether it appears in some disconnected region or not is irrelevant. Escape implies re-entry into the same causal domain. Teleporting into a separate universe with no causal link is indistinguishable from annihilation. There is no operational difference. Another refuge is the idea of wormholes. Perhaps black holes are entrances to tunnels through space-time. Perhaps advanced beings could stabilize these tunnels. This idea misunderstands both wormholes and black holes. Wormholes in theoretical models require exotic matter with negative energy density to remain open. Such matter has never been observed in macroscopic form. More importantly, even if traversable wormholes existed, they would not form spontaneously inside ordinary black holes. They are separate solutions with different global properties. Gluing them together is not a matter of clever engineering. It is a matter of rewriting the equations, and rewriting the equations breaks their agreement with reality. Furthermore, traversable wormholes introduce severe causality problems. They permit time travel. Time travel destabilizes the consistency of physical law. Modern theoretical work strongly suggests that mechanisms exist that prevent such configurations from forming, not because physicists dislike them, but because consistent universes do not tolerate them. Black holes, by contrast, are robust. They form under generic conditions. They require no exotic ingredients. They appear wherever gravity becomes strong enough. Nature produces them effortlessly. This asymmetry is telling. Structures that violate causality appear only in contrived mathematics. Structures that preserve causality appear ubiquitously. Escape from black holes requires causality violation. Therefore, escape belongs to the contrived category, not the natural one. Another subtle refuge is the belief that even if escape is impossible, communication might still be possible. That perhaps an object could not leave but could send a message. This belief fails for the same reason. Messages are physical processes. They propagate as disturbances in fields. Fields obey causal structure. No outward causal curves exist. No message-bearing disturbance can travel outward, not slowly, not weakly, not encoded in some exotic carrier. This is not a technical limitation. It is structural. Even hypothetical quantum entanglement does not allow information transmission without classical channels, and classical channels obey space-time geometry. Entanglement correlations do not carry usable signals. They do not transmit messages. They do not circumvent horizons. Thus, even the faintest whisper from inside a black hole is impossible, not because the signal gets absorbed, but because the signal never has a path. Silence is not imposed. Silence is inherent. At this stage, a pattern becomes clear. Every imagined workaround relies on sneaking in something that reality does not allow: backward time, negative entropy, exotic matter, causality violation, hidden dimensions with special rules. Each workaround asks for a universe that is fundamentally different from the one we observe, not a deeper version, a different one. But the black holes we are assessing are not speculative objects in such alternative universes. They are the black holes in this universe, observed, measured, mapped. Their behavior matches general relativity with extraordinary precision. This anchors the discussion. We are not debating metaphysical possibilities. We are analyzing consequences of the actual laws governing the cosmos we inhabit. In this cosmos, black holes are final, not symbolically, not poetically, operationally. There is no escape clause, no appeal, no loophole. This conclusion carries an implication that is easy to miss. It means that nature contains places where the story truly ends, not for individuals, not for civilizations, for regions of space-time itself. There are portions of the universe that do not have futures connected to us. They are not hidden corners waiting to be explored. They are excised from our causal domain forever. Human culture is saturated with narratives of survival, of narrow escapes, of last-minute rescues. These narratives shape intuition. They make absolute endings feel unrealistic. Black holes do not care about narrative. They do not operate on story logic. They operate on geometric logic. Geometric logic has no drama. It simply enumerates what paths exist. And inside a black hole, the list of outward paths is empty. The more deeply one understands this, the less meaningful the word trap becomes. A trap implies potential release. Black holes offer no such potential. They do not hold prisoners. They terminate participation. Crossing the horizon is not entering a cell. It is exiting the universe in every sense that matters, not by leaving, but by ceasing to have a future that intersects anything else. This is the core of the impossibility, not danger, not destruction, not violence, but disconnection from the entire structure that makes alternatives meaningful. Once the idea of escape collapses at the level of causality, a deeper discomfort emerges. If black holes truly sever futures, then the universe contains regions where history does not merely become unknown, it becomes unshared. This challenges a quiet assumption that underlies much of human thinking, the assumption that reality is fundamentally communal, that everything that happens within a single connected story. Black holes reveal that this assumption is false. Reality is partitioned, not metaphorically, literally. Space-time fractures into causally isolated domains. Each domain has its own internal sequence of events. Between domains, there is no mutual future. This is not philosophical speculation. It is a direct consequence of Einstein's equations. The equations permit horizons. Horizons permit disconnection. Disconnection permits multiple non-intersecting histories. Understanding this forces a re-evaluation of what it means for something to exist. In everyday language, existence is treated as absolute. Either something exists or it does not. Physics suggests a more conditional definition. Something exists relative to a causal domain if it can, in principle, influence events within that domain. If no such influence is possible, the concept of existence becomes operationally empty. From the outside universe, interior black hole events do not exist, not in the sense that they are hidden, in the sense that they have no physical consequences. They never appear in any future measurement. They never modify any external process. They are causally sterile. This is stronger than invisibility. Invisibility still implies presence. Sterility implies irrelevance. From the inside, the outside universe quickly becomes irrelevant as well. Signals from outside can still enter after the horizon crossing, but the interior cannot respond. This asymmetry deepens with time. The interior's future becomes increasingly self-contained. The outside fades into a theoretical memory. Eventually, only the interior remains meaningful. This mutual isolation is not negotiated. It is not gradual in a fuzzy sense. It is clean. Once the horizon is crossed, the partition is complete. This has a direct implication for escape fantasies. Escape requires that interior events eventually rejoin the external causal network, but the network does not contain reconnection operations. Causal structure does not include a merge function. Histories can branch, they can split, they do not recombine. Recombination would imply that two previously independent causal chains suddenly become one. This would create contradictions. Events in one chain would acquire multiple inconsistent pasts. Physics forbids this, not as a preference, as a requirement for consistency. Time is not a river that splits and rejoins. It is a partially ordered set. Some events are comparable, some are not. Once two events are not comparable, meaning neither can influence the other, no future operation makes them comparable again. This is a deep mathematical property of causal sets. Black hole horizons generate such incomparabilities. Once inside, interior events and exterior future events become incomparable. No later evolution changes that. This means that even hypothetical universe-scale engineering cannot restore contact, not because of insufficient power, but because there is no legal operation that transforms incomparable events into comparable ones. The structure does not contain that rule. Another misconception arises from the way black holes are often discussed as objects. They are spoken of as things that sit somewhere, as if they were gigantic planets. This framing obscures their true nature. A black hole is not a thing located at a place. It is a region of space-time with a specific causal structure. You cannot remove a region of space-time from itself. You cannot pick up causality and rearrange it. You cannot scoop out a horizon and replace it with something else, because the horizon is not made of stuff. It is made of relationships, This is why statements about destroying a black hole are misleading. You can reduce its mass. You can cause it to evaporate. You cannot erase the fact that in the past a horizon existed and partitioned spacetime. That historical partition remains encoded. And the causal ordering of events. Even if the black hole is gone, the separation that occurred while it existed cannot be undone. This is analogous to breaking a glass. You can melt the shards. You can reshape them into a new glass. You cannot make the original shattering never have occurred. Causal history does not rewind. Thus, even scenarios in which black holes eventually evaporate do not resurrect escape. Evaporation does not reach backward in time and reopen closed futures. It only alters what happens later outside. The interior histories still end. This leads to a further uncomfortable realization. Black holes are not merely local phenomena. They are global features of space-time history. Once formed, they permanently alter the structure of what futures exist. They reduce the set of possible global histories. They remove branches. This is a stronger statement than saying they trap matter. They delete options, not gradually, instantly. At the moment of horizon formation, all future histories in which the interior region reconnects to the exterior cease to exist, not because they become unlikely, because they are removed from the solution space. This also reframes the idea of falling into a black hole. From the outside perspective, an object appears to slow down as it approaches the horizon. It never quite seems to cross. From the object's own perspective, it crosses in finite proper time. Both descriptions are correct. This duality often confuses people. They imagine that perhaps the outside observer's infinite time view means escape is possible in some subtle sense. It does not. The outside observer's description is about how signals are received, not about whether crossing occurs. Crossing occurs. The causal partition forms. The outside observer never receives confirmation of interior events, but the absence of confirmation is not evidence of reversibility. It is evidence of disconnection. This is another subtle but important shift. Ignorance is not the same as openness. Not knowing what happens inside does not mean anything could happen inside. It means that whatever happens inside is irrelevant to the outside. The laws inside are still strict. The geometry inside is still defined. The future inside is still singular. The horizon is not a mystery curtain. It is a one-way cut in the fabric of cause and effect. Once one internalizes this, the idea of escape begins to feel not merely impossible, but conceptually incoherent. It is like asking for a square circle. Not difficult, not advanced, ill-defined. Escape presupposes a shared future between interior and exterior. Black holes eliminate that presupposition. There is no shared future. There are two separate temporal structures. One ends, one continues. They do not meet again. This is not tragic. It is not cruel. It is not malevolent. It is neutral. It is the logical outcome of a universe that obeys consistent rules. Rules that allow complexity. Rules that allow stars. Rules that allow chemistry. Rules that allow observers. The same rules also allow horizons. The same consistency that makes existence possible also makes certain endings absolute. Black holes are one expression of that consistency. They are not exceptions. They are confirmations. The finality they impose is not a flaw in physics. It is evidence that physics is coherent. At this stage, the impossibility of escaping a black hole no longer rests on any single argument. It emerges from a convergence. Geometry forbids outward futures. Causality forbids backward influence. Thermodynamics forbids time reversal. Quantum theory does not restore lost pathways. Cosmic engineering cannot alter past partitions. The conclusion begins to feel less like a dramatic claim and more like a bookkeeping result. And this is precisely what makes it unsettling. There is no villain, no catastrophic failure, no cosmic punishment, just accounting. Reality keeps track of what can influence what. Black holes sit at points where that accounting reaches closure. Another layer of discomfort arises when one considers that black holes are not rare. They are not anomalies at the edge of the universe. They appear wherever massive stars die. They sit at the centers of galaxies. They merge, they grow, they evaporate. They are a normal outcome of stellar evolution. This normality is important. It means that finality is not exotic. It is woven into the everyday life cycle of matter. Stars form, stars burn, stars collapse. Some collapses create regions from which futures end. The universe is not arranged to preserve continuity at all scales. It is arranged to obey local rules. Global consequences follow. Human culture tends to associate finality with moral weight. We look for meaning, for justification, for narrative structure. Black holes offer none. They are indifferent. They do not care what falls in. They do not select. They do not judge. They simply implement geometry. This indifference undermines another quiet belief. The belief that intelligence occupies a privileged tier of reality, that sufficiently advanced minds might transcend physical limits. This belief often hides inside phrases like post-physical or beyond matter. But no matter how intelligence is implemented, if it interacts with the universe, it obeys physical law. If it does not interact, it has no operational meaning. There is no category of intelligence that floats above causality while still participating in it. Participation implies constraint. Black holes constrain participation, not just for humans, for anything. This universality is crucial. It means that the impossibility of escape is not a human limitation. It is not about weakness. It is not about ignorance. It is not about technological infancy. It applies equally to hypothetical superintelligences, to distributed cosmic minds, to civilizations billions of years older than ours. They all inhabit the same space-time. They all face the same horizons. No mind can think its way out of geometry. No computation can compute a non-existent future into existence. Another comforting idea now collapses. The idea that black holes are temporary problems because the universe itself is evolving, that as cosmic expansion continues, perhaps horizons will weaken, perhaps new global structures will emerge. This misunderstands the nature of horizons. Cosmic expansion does not dissolve past causal partitions, it creates new ones. The accelerating expansion of the universe already generates cosmological horizons. There are galaxies receding so fast that light emitted from them today will never reach us. They are not hidden. They are gone in a causal sense. No future event inside our cosmic region will ever be influenced by them. They still exist locally, but not relative to us. This mirrors black hole horizons on a larger scale. The universe naturally produces regions that lose mutual futures. This is not astropathology. It is a generic feature of relativistic spacetime. Thus, black holes are not isolated curiosities. They are extreme examples of a broader phenomenon. The universe does not guarantee global connectedness. It only guarantees local consistency. Where local consistency leads to global disconnection, disconnection occurs. No appeal, no override. Another misconception that surfaces is the idea that impossibility must be symmetric. If escape is impossible, then entry should be impossible as well. But this symmetry does not exist. Causality is directional. Time has an arrow. Processes that are easy in one direction can be impossible in the reverse. You can mix cream into coffee easily. You cannot unmix it. You can collapse matter into a black hole under sufficient compression. You cannot decompress interior space-time back into an exterior connected region. The formation of a horizon is a one-way transition. This asymmetry is not arbitrary. It is grounded in entropy increase. Black hole formation increases total entropy. This increase is enormous. Black holes are the most entropic objects known. They represent maximal information hiding per unit area once such an entropy increase occurs. Reversing it would require an astronomically precise coordination of microscopic states, not approximate, exact. Any deviation fails. The probability of such coordination is not merely small, it is effectively zero. But more importantly, the causal structure prevents even attempting it from inside. Even if by some miracle interior states spontaneously aligned in an entropy decreasing configuration, there would still be no outward directed future in which to express that alignment. The geometry remains. This highlights a deeper theme. Black holes are not merely sinks for matter, they are sinks for alternatives. They remove branches from the tree of possible histories. When an object crosses a horizon, all futures in which it later influences the outside universe are pruned. The universe continues on a reduced set of possibilities. This pruning is permanent. The tree does not regrow those branches. In everyday life, mistakes feel reversible because most small-scale processes do not permanently delete macroscopic options. Black holes operate at a scale where deletion occurs, not metaphorically, literally. This also reframes the emotional reaction people have when imagining falling into a black hole. Fear is usually directed at pain, at suffering, at violent death. Those may or may not occur depending on black hole size and conditions. They are not the core issue. The core issue is termination of relational existence. You cease to be part of any future that includes the outside universe, not as a metaphor, as a structural fact. This is more profound than death as commonly understood. When a human dies on Earth, their body still influences the environment. Their atoms circulate. Their actions echo. Their effects persist. Inside a black hole, persistence relative to the outside ends. No echo returns, no influence propagates. The universe continues as if the interior never happened. From the outside perspective, it did not. This does not make black holes supernatural. It makes them brutally ordinary in their logic. They do exactly what the equations say. No more, no less. The sense of horror arises not from cruelty but from clarity. Black holes show what a universe looks like when its rules are followed to their logical endpoint. Not softened by narrative, not padded by exception. Just consequences. The impossibility of escape is one of those consequences. It is not a dramatic proclamation, it is a bookkeeping entry, and the ledger has no column for return from inside a black hole. By now, it becomes clear that every imagined loophole collapses under the weight of consistent physical law. The universe allows complexity, but only within the constraints of its structure. Black holes represent a boundary where those constraints reach their maximum expression. Consider the notion of energy. Energy is conserved. It cannot be created or destroyed in any ordinary sense. Yet this principle, so central to all physics, offers no way out. One might imagine harnessing energy inside a black hole to propel oneself outward, perhaps convert mass to energy, fire it in the right direction, generate a counterforce. But every pathway available for energy release points inward along the curved geometry of spacetime. There is no outward in which energy could propagate to change the trajectory